Okay, we're gonna change. Okay, guys, go back to the definition of root locus. Which page is that? Wait. Yeah, here you are. Okay, so simply that it is showing you the location. Yeah, it is the plot that shows you the location of closed loop poles of the system for every K that you vary. Yeah, okay. All right. So that's 13 of you, isn't it? All right. Okay. After the definition, yeah, you look at page 11. Yeah, and please understand. Yeah, how you have um, try to understand. Yeah, how is the K and what it is related to the closed loop poles. Yeah, in the tedious way of solving the location of closed loop poles. For this example, page 11. Okay, so this is tedious way of getting all the closed loop poles for only six, yeah, um, six value of K. Okay, but yeah, even though this is tedious, but it shows you, yeah, the what is the meaning behind. Okay, the meaning behind the root locus itself. Where's the rest of your friends? I still have 14 of you only. Shall we? Shall we start? Are you ready, guys? Yes. Yeah, shall we? Okay. All right. So from this example, you can see that when you use K equals to 0, you put it inside the calculation of your closed loop poles, you get all these answers. Okay, for K equals to 0, you have your closed loop pole there. The next is K equals to 1 there. The next is there, and so on. Okay, so this is one by one. But instead, if you learn how to sketch the root locus by the 8 rules, yeah, you can immediately get the root, okay, without having to calculate each of the closed loop poles according to the different K. Got it? Yeah. Okay. So now today we're going to start. Yeah. Learning how to sketch the root locus. Yeah, with 5 basic rules, which you can understand it very quickly. Yeah. Okay, because it's not so difficult. Yeah. The 5 basic rules. That's why it is called basic. Okay, because it's simple, it's easy to apply. Okay, now the first one. It says that the number of branches equals to the number of closed loop poles. Okay, branches. What does it means with branches? Branches is the root. Okay, branch. Okay. like when did I, okay, like this example. Remember this example? Okay, I draw for you this one. Yeah. How? Yeah, with the 5 basic rules. Okay, I use 4. Yeah, 4 basic rules. I can sketch this. Yeah. Okay. Now look here. Can you see my lines?
Yes.
Yes, Sultan.
Good. Yeah. Okay, so that is the explain. Yeah, explain. And then I will use blue color. Yeah, blue color can, or red. Red first. Yeah. Okay, red to mark, yeah, the all the open loop poles and the open loop zeros from the open loop transfer function. Okay, all right. So here I have open loop. Okay, let me allow your friend here. Okay, Shahir, welcome. Okay, so from this previous example that we have done, okay, I'm showing you the root locus now. Okay, guys, okay, look at the transfer function. This is open loop transfer function. So the open loop zero. Okay, I have to write it very slow. And also open loop. What happened? Yeah, open loop pole doesn't work. Why? Last week okay je. Okay, this is open loop pole. Okay. So difficult to do this. Okay, all right. So okay, for the open loop 0, you have -4, -3. Open loop 0, okay? -4, -3. Why? Because you know this is open loop transfer function. Equating the upper part to 0, you get your open loop 0, right? Okay, now for the open loop pole, you have S equals to -1 and -2. Okay, all right, now, if I want to draw, yeah, I have to put them, yeah, onto this S-plane, yeah, -1, and then -2, and then you have your -3, your 0, and -4, your another 0. Okay, all right, so that's how you do it first, yeah, and then oh, never mind, yeah, change color. Okay, I want to show you how the root locus look like for this one, yeah. Ish. What happened? Wrong. Let me fix this one. Wait. Okay, nanti confused. Okay. Alright, now I'm going to draw the root locus. Okay, in blue color. Okay, hold on, Larry. Okay. Okay, guys who just joined us, yeah, I'm showing to your friend, yeah, about how to draw the root locus. Kenapa biru ni must appear? Still appearing. What happened? Oh, I don't like it. Okay, all right. Sorry for the technical things here. Okay, yeah. Okay, first of all, yeah, you just draw your S-plane, and then you put in your the open loop poles and open loop zeros onto your S-plane. Next, yeah, I'm going to show you how I can draw the root locus based on the 5 basic rules. Yeah, okay, so it will be like this. Okay, all right, this is actually the arrow, yeah, that I'm drawing. Okay, from the one of the open loop pole out from it. Okay, you draw one arrow, and then another the second open loop pole, you draw another 0 from it, yeah, from it, yeah, heading out, okay, from the open loop pole, and then okay, when they meet up at one point that you will calculate using the additional rules, okay, they will break out. Okay, finding what? Finding the 0. Okay, so the two zeros are on the real axis. So you have two poles there that is going to be getting into the each of the zeros. Okay, so one would be picking one of the 0, another, okay, so now the arrow will be 2, yeah, into the 0. Okay, another heading out from the pole, and then also similarly going to get into the other 0. Finish. Okay, so that is how you're going to draw the root lockers. Okay, so you're looking at a pair of pole and a pair of 0. All are finite values. Finite. Okay, finite value, so they match the number of each other, okay, 2 with 2, okay, so one would go into this, another into that the other one, okay, so you can see that they breaks out from the real axis here, and then it breaks into the real axis here, okay. All right, now don't worry, yeah. We will go to the 5 basic rules in another 1 minute. Okay, now what I want to say about branch is one root from the pole to the 0 is called one branch. Okay, so here, how many branches that you have?
Two.
Two, right? Okay, one, and then another one is down here. Okay, so you have two branches. All right, now back to the page 18 just now. It says here the number of branches must equals to the number of closed loop poles or the open loop poles. Yeah, it's okay because number of closed loop poles would also the same with the number of open loop poles. Yeah, so number of branches. So here, looking at this open loop transfer function, open loop transfer function 1 over s. Okay, so first thing first, is this too small in your view? You want me to zoom? Is it better this way? Yeah. Oh, okay. Yeah. Nanti saya adjust lah. Yeah. Okay. Here, if you can see, okay, when you get the open loop transfer function of a system, okay, first of all, you have to identify, okay, what is there any open loop zeros, and what is of the open loop poles? Okay. So in this case, do you have any open loop zeros for GS?
No.
No, none. Okay, so nil or none. Okay, that is for the open loop 0, none. Yeah, and the open loop pole, you have S equals to 0, isn't it? Yeah, 0, isn't it? Yeah, S to 0. Yeah, so S equals to 0, you put there. So here is none or nil. Yeah, NIL. Okay, all right. Now you can see that the lockers, yeah, for this one, okay, how I do this is, okay, this is 0. Yeah, so this is very small. This is from the programming actually. Yeah, okay, so this is very small, but it's actually pangka is the cross mark there, very small. Yeah, probably you cannot see. All right, so this is the pole, no 0 to go. So where does it go? It will find the infinite 0. Okay, and this is 0, 0, and then it will go this way. Now there's a one question here. Why it go to the left? Why does this goes to the right side? Betul tak? Yeah, there is one question that you have to hold on. Okay, because you will get that in the next rule. Why it goes to the left? Now the thing is that this first rule says that the number of branches must equal to the number of closed loop poles or the open loop poles. Here, the number of your open loop poles is 1. Right? 1. So it means that your branch is also must equals to 1 only. So you have one branch. Okay, now let's look at the next one. Okay, here you have open loop pole. Yeah, open loop poles you have s equals to 0. How many times? I cannot hear voice, guys. I cannot see you, but I need to hear your voice. Come on, guys. How many poles do I have here?
2,
2. At
0.
yes, twice. Okay, so it's actually that you have here your your pole at 0 twice. There are 2 open loop poles there at 0. Okay, now remember from this row it says that it must be according to the number of poles, right? So you have 2, it means that you should have 2 branches. Okay, so it means that it goes 1, okay, 1, it goes, oh, terrible. Okay, so it means that 1 goes up there, another goes down here. Yeah, okay, so you have 2 branches of root locus. Okay, now this is another question, right? Why it does it goes up? Why does it goes down? Wait for the, I think it's the fifth rule. Yeah, about the infinity. Yeah, asymptote. Okay, now next. Let's look at what you have here. You have 3 open loop poles at 0, right? Okay, so you are expecting, yeah, or you need to draw 3 branches. Okay, and here you are, yeah, at 0, yeah, the pole at 0, the origin, yeah, s equals to 0 there. Okay, so here you have 3 cross marks at the same point. All right, and from them, yeah, you have to draw out, yeah, 3 branches. Okay, why do we have the drawing looks like this, like a star, yeah, this way, 3 branches out. Okay, this is from the 5th rule. Okay, all right, that's how you learn about the first rule. Yeah, the number of branches must be the same with the number of your closed loop pole. Yeah, okay, now next, any question until there?
No.
No.
Not yet, yeah. Okay, hold on. Recently, I updated my Acrobat. This is using the Acrobat DC. Yeah, after I updated the Acrobat Adobe, yeah, it becomes so slow. Yeah, ni ada keluar apa pula ni? Repair. Oh, come on. Nanti. Okay, root locus is symmetrical. Now, okay, look at this two root locus. Okay, I make it bigger. Yeah. So what do you have here? Okay, the open loop poles, you have 2 points there, here and here. The zeros, the open loop zeros, you have 2 locations there. Okay. Now one out from the root locus, out from the open loop pole there, yeah, goes to one of the zeros, another, yeah, out from the pole going to the other 0. Okay, this is like the example that I used before. Okay, it's just that it is opposite, right? The zeros were here, the poles were there. Yeah. Okay, so you can see that according to the number of your open loop poles, you have two branches. Yeah. Okay, now let's look at this one. Yeah, similarly, yeah, the locus starts from the poles going out, finding the zero. Okay, you have two branches. Okay, now from this rule, it says that they need to be symmetrical about the real axis. So what is real axis? It's here, isn't it? Right? This is your imaginary. This is your real. Okay, you can see that your when you have a root locus that breaks out into the complex area, yeah, you can see that they need to be symmetrical, yeah, about the real axis. Okay, mirror, right? You can see. Okay, same to this the right side of this example. Okay, very simple, isn't it? Up to here, you have learned two already. Okay, any question?
No.
Nope. Okay, next. Please, yeah, raise up your hand. Ada raise kat situ kan? Yeah, virtual hand kat situ. If you want to stop me or you want to ask question, please do so. Okay, the next one, third. Yeah, all right. What if I have, yeah, how do I decide, yeah, the direction of the root blockers, whether it needs to go to the left or it needs to go to the right? When you have the open loop zeros and open loop poles on the real axis, okay. Now nampak ni, ya, real axis. In the case, ya, for the open loop zeros and poles that are on the real axis, how to go about it? It goes to the left or goes to the right? Right? Yeah, we want to know. Okay, so this is the rule that you have to follow. It says that, yeah, for those on the real axis, you just count them, yeah, the odd number. Okay, so here you have one, the first, the second, the third, and the fourth. You just count it. Yeah, the first, second, third, fourth. So the odd number is this one at -1 and also this one at -6. Okay, now the odd number of those need to have the locus axis to the left, on its left. Okay, so you can see here. Okay, this is first, this is second. Okay, true. Yeah, sorry for that. This is third, this is fourth. Okay, right, first, second, third, fourth. Okay, odd number is this one and this one. Locus exists on the left of the odd number. Left is here, isn't it? Can you see that? Do you understand what I mean? Hilang pula. Dia. Nah, do you understand what I mean? Yeah? Okay, so it means that, okay, it means that for the even number of either the poles of zeros on the real axis, yeah, should have the locus on the opposite side, which is the right side. Okay, so that is what happened here. Yeah, even number is the other way around, on its right side. Okay, so that is why you know already now. Okay, locus exists between them. Okay. All right. Now let's look at the previous example. This one. Okay, shall we count this? First, second, third, fourth, right? Or obviously this and that. Okay, please check whether it complied the rules just now. The odd number must have the root locus exist on its left. Is that complying the rule?
No.
No? Are you sure? The first is here. Can you see that? The first is here.
Cannot see better.
I cannot see. You cannot see? Okay, jap. Okay. Maybe too small. Okay, itu dia. Yeah. Okay. Can you see clearly now for this one? Better? Okay. All right. So you just have to count it, right? So 1 is here, the odd number, and the third is here. Right? The odd number. Okay. So the third rule says that, yeah, locus should exist on the left of the odd number. Left. So you have it here. And then for this one also on the left. Is it? Okay. So for the even number, it's the other way around. Yeah, is the on the other direction. Okay, which is on the right. Yeah, of those pole or zero. You see? So now you know from rule number 3, the locus should exist between those poles and zeros. That is third rule. Okay, jangan pula you lukis, okay, you want to draw this kind, okay, locus on the right of the zero there. No, it's wrong already. You are not following the third rule. Because odd number should be on the left side. Do you understand what I mean?
Yes.
Yeah? Any question so far? Okay, you can check for all, like this one, yeah, this one. Okay, this one you have pole, yeah, pole. Pole here and also another pole here. Okay, there are only 2 poles, no zeros on the real axis. Okay, because the zero, yeah, the conjugate, yeah, complex conjugate points. Okay, hanging kat situ, hanging in the complex region. Yeah, okay, on the real axis, that is what you are focusing on. Yeah, because the rule says so. Yeah, on the real axis, yeah, you're looking at, okay, there are only 2 poles there. Okay, so just count it. This is the first, this is second. Okay, the odd number is just this one. This is first. Okay, this is second odd. Yeah, okay, so since you have one odd there, yeah, you must make sure your locus need to exist on the left side. Yeah, left. And since this is even, so it is in the other direction. Okay, so now you know on the real axis, the rule locus exists between these 2 poles. Okay. Okay. Now let's look at the next one. Yeah. Okay, so that's third. Let's look at fourth. Yeah. Okay, easy. Yeah. Yeah, number 4. What does it say, guys? What does it say? Root locus? starts from the pole, ends at zeros. Yeah, so that is what we have been doing. Yeah, it's always that I told you, yeah, many times, that the direction, yeah, it starts from the pole towards the zero. Okay, it means that, yeah, at the pole, when it starts at pole, yeah, the k at that time you picked at zero, k equals to zero. Okay, do you remember this one? Which page is that? The example. This example. If you can recall, yeah, this is the first slide that I showed you, right, today. Yeah, to recall the definition of root locus. Okay, when you try calculate the closed loop poles for different k 0 to 5, yeah, each time, yeah, you have to calculate and you will get answers, yeah, about the closed loop poles. When you set k equals to 0 inside there, you will get your closed loop pole solution at -6. Okay, there you are, this is -6. Okay, so this is -6. Okay, kuningnya let's change, yeah, blue. Okay, all right, so that's -6. Next, k equals to 1, you have -3, and so on. All right, so you pick k, you will get your answer. You pick another k, you'll get another closed loop pole, and so on. So it starts from 0, starting at pole from k equals to 0 until very, very big k. You still have it just nearing the open loop 0. Okay, all right, so that's back to the basic. Okay, all right, so that's it. Yeah, the 4 basic rules. Okay, we'll go to the 5th. Yeah, okay, so you can see that here, from pole to 0, from pole to 0. So you can see that now it's out from the pole, it's out from the pole, and it goes into the 0. So if you want to draw this one, yeah, let me draw this. Okay, so it is out, out. Okay, and you will meet up at one point that you're going to calculate using the additional rule. It breaks out at a point that you will calculate and goes, yeah, and go out finding available finite zero. So you have two finite zero there. Yeah, that's why it bends and goes into the real axis. So you call this point as a break in. Okay, so one branch would go to 1, 0. Another would go to find another 0. It cannot be one pole to two zeros. Yeah, so you must make sure that one pole to 1, 0. Okay, all right.
Yes.
Okay, any question so far? No, yeah, then I will continue with the 5th one. You don't have to worry, you just have to be brave. Yeah, when you get any kind of open loop transfer function, you just follow the rules. Yeah, you follow the rules one by one carefully. Okay, you will definitely can draw. Okay, you can draw. Okay, at least using the 5 basic rules is enough to draw a basic simple sketch. Okay, to do the refining, okay, the breaking, the breakout, the crossing at geometric axis, for instance, okay, you have additional rules, another 3. Yeah, okay. Now this is the 5th, yeah, from the 5 basic rules. Okay, it says that, yeah, Okay, when the locus approaches straight lines or asymptote as the root locus approaches straight line or asymptotes. Okay, all right. When the root locus approaching when the root locus needs to go to infinity, okay, you need to draw or get the asymptote line. Yeah, so that you can use the asymptote line, yeah, to guide your locus that goes towards infinity. Do you understand what I mean? Okay, when you have a root locus that needs to go to infinity, yeah, you have to calculate an asymptote line to guide it. That is what I mean. Yeah, so the asymptote line, yeah, you can get it from these two equations. Okay, the first one, you need a point. The second is the angle. All right, when you have a point and angle, you can draw the line, right? Because it's like a vector, right? Okay, now let's look at how, yeah, in the case that you need the asymptote line calculated. Okay, let's look at these two examples. All right, now here for the first one, you know that the number of the number of open loop pole and the number of open loop zeros match. Okay, 2 with 2. All right, so you know that there is no branch that needs to go to infinity. Are you clear? All right, now let's look at the bottom example. Right, now you have 3 open loopholes, you have 1 zeros, doesn't match. Okay, so it means that 2 of the open loopholes need to find the infinite zeros. Is it? So when it looks for infinite zeros, it means that it will go towards infinity. Okay, in such case, when your locus needs to go to infinity, you need to calculate the asymptote line. Why do you need that? To guide, yeah, to guide how you can draw the locus. Would it bend to the right side? Would it bend to the left side? Or would it go straight up, straight down? So how does it go? You don't know, right? So you need a guide line, a guiding line, which is the asymptote. Okay, all right. So this is where you need to, yeah, make sure, yeah, you know how to use the asymptote. Okay, based on the um, calculation just now. The calculation is very simple. It's not difficult at all. Yeah, so this is very simple. You just sum. Yeah, sum all the points of your poles minus that. Yeah, the sum of your all your zeros if available. Yeah, and then you just minus that the number of poles minus the zeros, and then you'll get your point. Okay, for the angle is just 2k plus 1 pi. 2k plus 1 pi is odd multiplication. Why? Because k is 0, yeah, 1, 2, 3, and so on. Yeah, k. Okay, so when you put integer number there, you always get, because this is 2k even number plus 1 is odd. Okay, odd. Always odd, have odd number there. Okay, so it means that gives you pi, 3 pi, 5 pi, and so on. Okay, don't forget it need to be divided with the number of these, the difference of poles and the zeros. Okay, now let's take one example. Yeah, take one example. A simple one will do. Okay, let's take okay, I draw here. Okay, okay, all right. Let's say that I have a, okay, all at -1 and pole at -2. Okay? Alright. Now, let's draw the root locus. Yeah? Based on the rules that you have learned. Shall we? Yeah? Okay. Rule number 1, what does it say? Tell me. Guide me. Guys? Anybody? What does it
Number of
say?
branches.
Number of branches. Okay. Now, how many open loop poles that you have? In
2.
this example, 2. So, how many branches? Tell me.
2.
2.
2.
Yeah, you're expecting 2. Okay? Alright, 2 branches. Okay, hold on up to that. Okay, number 2. What does it say?
The root locus symmetry.
Symmetry. So you need to make sure that if it breaks out, it need to be symmetrical about the real axis. Okay? Alright, number 3.
Real axis to the left for the odd number
Mm.
on the
Okay.
real axis.
Okay, tell me now, how should I draw? I mean, root locus in between them, or one to the left, one to the right? So tell me how. Root locus on the real axis.
-1 to the left, -2
To
to
the
the
left, okay.
-2 to the right.
Yes, thank you. That's good. Okay, any question? Who answered me just now? May I know?
Saya
Nama?
Nur
Sebab
Alia.
saya switch off my view. Apa?
Nur Alia.
Alia. Thank you, Alia. Okay, guys, can you get it? Anything to ask?
Yes.
Okay, yeah, boleh eh? Okay, so that is third. Okay, number 4. What does it say?
Begins at poles
Mm.
and ends at 0.
Okay, it starts from, yeah, it starts from the pole to the 0. Okay, is it good to have yellow or maybe red? I change to red, yeah. Takut tak nampak. Okay, alright. Now it says that it starts from pole to 0. It starts from, so meaning that my arrow should be out from the pole. Also for this one, out from the pole. Okay, out and then must go to the 0. But is there any finite 0 to go to? Ada tak 0 for the locus to be heading to?
Tiada.
It's not finite, right? Yeah, tak ada in this case. Yeah, for this system, you don't have 0. Yeah. Okay, so it means that it needs to go out and finding your infinite 0. So it means that number 5 you have to calculate. Yeah, number 5 you have to calculate the asymptote point and the asymptote angle. A is for the asymptote. Okay, like in this example, okay, this one, the first one here, no locus that goes to towards infinity, finding the infinite 0. No. Yeah, none of the locus that goes to infinity. So it means that you can just skip number 5. Do you understand what I mean? You don't have to calculate the asymptote. What for? You don't need it. You don't need it. Yeah? Alright? You don't need the asymptote line. Don't need means you can skip. No locus that goes towards infinity. That's the reason why. Okay? But in my case here, okay, I have 2 branches and these 2 branches, both branches needs to go out to find the infinite 0. Alright, now for that I have to calculate my asymptote. Okay, let's calculate very quickly. Okay, the sum of pole -1 -2 sum. What do you get? -3, right? Yeah, Minus 3 minus nothing, 0. Divide by how many poles that you have?
2.
2. Okay, so your answer is?
Negative 1.4.
Yes,
1.5.
yes, 1.5 or 3 over 2. Okay, so what about the angle there? Kira lah kan. Okay, so theta, the theta angle, okay, 2k plus 1. I pick k equals to 0. The first one, yeah, k0. Now I know that two locus would go towards infinity. It means that I need two angles. Can you get it? I need two locus that goes towards infinity. I know that two would go towards infinity. Yeah, it means that I need two asymptote line. Two asymptote line originating at minus 1.5 means that it need to have two angles. Okay, so here k equals to 0. I start with k equals to 0. You have pi, right? So you have, mana pen dia? Okay, so I have two answers there. One is pi over, don't forget, you have division there. Yeah, so how many poles? 2, right? Find zeros, you don't have any zeros, so that's 0. Yeah, so how many? You have 2 poles there. Number, this stands for number, right? Yeah, so pi over 2. Okay, for k equal, when you set k equals to 0, you have your answer pi over 2. The next one, when you set k equals to 1, you have 3, isn't it? Okay, 0, sorry, tadi 1 pi, next is 3, 3 pi, k equals to 1, you have 3, okay, 3 pi. Okay, so you have 3 pi over 2. Okay, so you have two angles for the two asymptotes. Got it? Okay, I put it here for you. Oh, mana dia? So, tutup berat. Tutup jap. Okay. Okay. So here I put it there. Yeah, this is when you set k equals to 0. This is when you set k equals to 1. Yeah. Okay, now let's draw. Yeah, let's draw. I will use green color. Green color. Okay, make it bigger. Yeah, bigger. Okay, I hope that you can see that. Yeah. Okay, now minus 1.5 pi over 2 and 3 over 2. Can we draw? Yes, can. Where is my minus 1.5? It is exactly in the middle. Anis, is your internet okay? I can see that some of you keep leaving the GM and then joining back, yeah, because of the internet, yeah, I believe. Okay, so if you miss anything, please ask me so that I can repeat for you. All right, now let's draw the asymptote line. Minus 1.5. First of all, you mark the point. Okay, where is your asymptote point? At minus 1.5, it is in the middle, exactly. Yeah, and then you know the angle, which is pi over 2 and also 3 pi over 2. Where is that pi over 2? Straight up, right? Okay, and then 3 pi or 3 over 2 pi is straight down. Okay, so that is pi, and this one is 3 pi. Okay, can you see that? Okay, I just buangkan saja dulu. Ini, sorry lambat sikit, nanti dia keluar balik. Okay, come back, please come back. Okay, alright. Oh, itu dia. Okay, So you have the asymptote line drawn on the S-plane. Okay, and it says that you need to use it to guide your root locus. So how can I draw the root locus now? Yeah, I use my red color again, yeah, for the locus. Yeah, the green is the asymptote lines. Okay, you can also do that when I ask you to draw in your assessment, for example. Yeah, you can use different colors, okay, to show the difference between the asymptote line and also your locus. Okay, now, okay, this is the guiding line. Okay, it means that now my locus would be one is towards okay, sekejap. Sekejap ya, saya gunakan lain punya cara. Okay, so one goes up towards this line. Yeah, nearing, not crossing. Nearing. Okay, in mathematics, you use asymptotes as the guiding line. Asymptotes, ni dalam maths ada. You learn that. Okay, and you always use it as the line that when you plot your points, yeah, your points need to be nearing your asymptote line. Okay, because it is the reference or guiding line. Yeah, okay, so same goes to the second locus, also going downwards, yeah, following the guiding line. Can you see that? Okay, now I will put my arrow there so that you can see which one is the root locus. Okay. Here you are, you finish your root locus for this example. Any question? Okay, take this example, put it in your note. Yeah. Okay, so 5 basic rows you can sketch already. So it is important to really understand it. It's not difficult, isn't it? Yeah. The one that involves calculation is just number 5. And yet the calculation is just simple total number. Okay, total number and also the sum. Yeah. Any question? Guys, I don't have any answer from you.
Not at the moment, doctor.
Not at the moment. Okay, thank you. All right. As exercise, okay, you can try out this one. Write out nilai K tu just pick car. Wasting. Yes. Okay. Thank you for that question. Yeah. What about the K? Yeah, K is not the big K, right? The big K is for the game. Yeah, K is small K. You just pick any number. K 0, 0, 1, 2, 3, 4. Can you write it down? K is just integer. You can take negative, pick positive, easier. Yeah, positive number so that you have positive angles. Yeah, okay. So positive 0, 1, 2, 3, and so on. Yeah, positive integer, you always get odd multiplication of pi over here. Odd multiplication of 180. Pi is 180. Yeah, 180. Got it? Okay, so like in this case, I repeat. Okay, thank you, Mr. Okay, I repeat. Yeah, in the case where you have to look at your open loop poles and zeros. Okay, using the 4 basic rules just now. Okay, you have you have the understanding. Okay, how many branches? Left, right. Yeah, from the third rule, right? Okay, and then you found out, no zero, so it needs to still going to towards zero. No finite zero means that it goes to infinite zero. Okay, how many that goes to infinite, into infinite zeros or infinity? Okay, 2 branches that would go towards infinity. Okay, so when you have 2 that goes towards infinity, automatically you know that the angles that you have to calculate must have 2, because you need 2 lines. Alright, so for that, after you pick k equals 0, you need another one. Okay, pick another one, k equals to 1. If there are 3 locus branch that goes towards infinity, let's say, yeah, so it means that I have to increase another one, k equals to 2, to get another angle, which is 5 pi over 2. If you have 4 locus that goes to infinity, you increase another one, 0, 1, 2, 3. Is that? It depends on how many that goes towards infinity that you have to guide it. Guide the locus. Okay? Alright, back to the question. Okay? Alright? So in this case, how many that goes towards infinity? In this case, 2, isn't it? Okay, so it means that you use k equals to 0 and k equals to 1. Yeah? Okay, so you have, okay, here you have 3 there. So 3 minus 1. Number there. Okay, look at here. Okay, pick this example. Okay, I'm talking about this example now. 3 poles versus 1 0. Yeah? So 3 poles minus 1 0. 3 minus 1 what do you get? 2, isn't it? Yeah. So you have 2 locus that goes towards infinity. So meaning that you will have your answer as pi k equals 0, pi over 2, and also 3 pi over 2. Yes, same answer like this one. Okay. For this example. Okay. All right. I hope that you get it. Yeah. The 5 basic rules. Yeah. So you have another 3 rules to learn. Yes. Okay. Let's have a break. Okay. Okay. During the break, I give you 10 minutes break. Lama Okay. But during the break, bagilah sikit ya. Okay. We are going to learn about, first is the breakaway and breaking points on the real axis. Okay, and it involves this equation. It involves this equation. Okay, so this one and also this one. Okay, I will explain. Okay, and then second rule, we're going to learn J omega axis crossing. And for that one, this is your friend. Yeah, during your diploma. You all diploma, isn't it? Okay. Kalau matrix, I think that they learn this in semester 3. Okay. In your case, during your diploma, you have learned this. Yeah, your friend here, Ruth table. Okay. You don't have to worry. Okay. Maybe you forgot about how you calculate it. Yeah. Now is the time you recall. Look at the table. Look at the symbols there. How are you going to solve it? Yeah. What is the operation to solve this? This is what do you call it? I pun dah lupa nama dia. Okay, so it is the determinant, right? Yeah, determinant calculation. Yeah, A4 times A1 minus A3 times A2. Okay, just recall for during the break, okay, about these equations. Okay, we'll come back at, wow, 9:10 already. 9:20. 9:20 we'll come back. Okay, to cover these rules. Okay.
Okay, doktor.
Baik. Okay, guys, are you ready?
Yes, ready.
Okay, shall we? Yeah. Okay, let's start again. Yeah, the sixth rule, which is part of the refining rules. Okay, to sketch when you sketch your root locus. Okay, the first one is the breakaway and break-in calculation. Yeah. Now let's look at one page before. Okay, this example on page 24. All right. Now it's clear that you need to calculate the point there so that you know where does it breaks out. Okay, breaks out. Yeah, you know that it goes towards the zero there, isn't it? Yeah, it goes towards zero. So we have to calculate, we have to know what is the breakout point, okay, of the root locus. And when it goes to zero, you now need to know what is the break-in point. Okay, so that is why it is called the refining rules. Yeah, you have to um, refine it. Okay, calculate more accurately. Yeah. Okay, what about this one? Okay, you have the breakout point only that needs to be calculated. Okay, you don't have the break-in because it goes towards infinity. It doesn't goes into the real axis anymore. It breaks out, breaks away. Yeah. Okay, for this one, yeah, you don't have anything. You just straight, yeah, from the pole to the zero. Okay, all right. That is what it means by the sixth rule. Okay. Now, what are the equations that you can use to calculate this? Yeah, is you have two options. Options. Okay, it means that you have to select. Okay. All right. Which one you are comfortable with? All right, now, the first one is this one. Yeah, the summation of that equals to the summation of that. Z is the zero, P is the pole available in the open loop transfer function. Okay, the open loop zero there, open loop poles there. Okay, so if you have several, for instance, you have two zeros, Z1 and Z2. Okay, it will be, yeah, 1 over, so the sigma there you can just replace with S. S. Okay, you just replace it with S. Okay, the sigma there. Yeah, so 1 over S plus the first zero, Z1, plus, because this is sum, right? Sum of that fraction. Okay, 1 over S plus the first Z, Z1, plus 1 over S plus Z2. Okay, so that's how you use the equation. Okay, similarly, if you have more than one pole, yeah, you just increase it, yeah, because this is sum, you just increase it by plus. Okay, plus. Okay, plus. Okay, if you have two poles, for instance, yeah, 1 over S plus P1 plus 1 over S plus P2, yeah, and so on, yeah, if you have more poles. All right, now, secondly, yeah, you have this simple equation. It's not difficult. This is familiar to you, isn't it? This is the characteristic equation of your closed loop transfer function, right? 1 plus kg ish equals to 0. Rearranging that, you will get this one. Okay, remember this looks like your property for the magnitude, right? Locus. But you take the modulus. Okay, guys, I have to switch off my video, yeah, because my battery is very weak. Okay, right, yeah. All right, so from here, k equals to that. Yeah, now next, once you have rearranged your equation to be like that, leaving the k only on the left side, next is that you just differentiate that right equation on S. Okay, equate it to 0, you'll get your solution. Okay, so like this one, yeah, when you get the left and right side equation written, yeah, you can rearrange that and solve for the S. And the S solution is actually give you the information about the break-in or and breakouts. Okay, some lockers you have both, some you just have break-in, some you just have breakout only. Get it? Yeah. Okay, now let's look at one example. Yeah. All right, here. Okay, so what do you have here? Okay, let me make it bigger. Okay, look here, example 8.3 down there. Okay, here you are. Yeah, so what you have here is that you are given with a system with the open loop transfer function as that. Okay, this actually comes from this block diagram. Can you see this block diagram? Can you see that block diagram?
Yes,
Yeah,
madam.
can ya? Okay. From this block diagram, you need to write down the open loop transfer function. Yeah. So here you have K with this block, the plant's transfer function on the forward path. So meaning that you have to take them together, multiply them. Yeah. So K times that one times H equals to 1, right? H is equals to 1. So KGH is your open loop transfer function. It means that K times that is that equation. Yeah, of what you should get. Yeah. Okay, now next, okay, let's say that I want to use the transition method. Yeah. Okay, transition method. Now you know that you have your open loop 0 at 3 and 5. Okay, that is why you have to write down. Yeah. Okay, so here, okay, let's say that okay, I put it there. Open loop. Okay, so big. Let me make it smaller. Okay, I think I hope that we can still view. Yeah, s equals to 3 and 5. Okay, and then for the open loop hole, yeah, you have s equals to minus 1, oops, minus 1 and minus 2. Right? Okay, now how to use this? Okay, as I've said just now, yeah. Okay, you just put it inside the equation 1 over s plus 3 plus 1 over s plus 5 equals to 1 over s. See? Okay, hold on. That's not how you do it. Okay, let me repeat. Yeah, let me repeat. Okay. I think I would need my pen. Okay, here you are. Yeah, because plus and minus is important here. Okay. Right. So the first one, you have to look at how you use this is based on what you look at the equation or the block diagram. Yeah, you take 1 over s plus or minus of that in the equation. Okay, all right. So it means that it becomes 1. Okay, 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 right. So it becomes, where's my pen? Okay, 1 over s minus 3 plus s minus 5. Okay, equate it with 1 over, okay, what do you get? S plus 1 plus s plus 2. Can you get it? Yeah, 1 over s minus 3 plus, yeah, 1 over s minus 5 and then s plus 2 and s plus 1. Okay, now solving this, you will get your answer. Try this please, yeah, at home. you have to rearrange this, solve the S. Okay, so since it is at the bottom here, it means that you have to do the cross multiplication, isn't it? Yeah, cross multiplication, right, to solve the mathematics there. And here, this is second order, you should have two answers. Okay, the two answers is given to you already. Yeah, one is minus 1.45, another is 3.82. Okay, now which one is breakaway and which one is breaking? Okay, that's why you need to have the drawing first. Okay, all right. So since this is under the rule, yeah, as an example, actually you have to draw first. Yeah. Okay. Let draw quickly. Yeah, let us draw quickly. This one. Okay. Okay, make it smaller. Yeah. Okay, let's draw. Okay, quickly. All right. Okay. Right. Yeah. Okay, what do you have? 3. Oh, 3. 3 is over there. Yeah, 3 and 5. And then minus 1, minus 2. Yeah. Okay, the scale is not good at all. Yeah. Let me draw one more time. Okay, one more time. Okay. Right. 3 and 5. And then minus 1 and minus 2. You can also draw here on your notes. Yeah, please try the 5 basic rules. Draw it big enough on your page. Yeah, jangan kecil-kecil, besar-besar. Yeah. Okay, now locus. Yeah, you know that. Okay, I change color. Blue color. Okay, out from it, out from this. Okay, remember third rule, left, right. Okay, left, right. First, third. Okay, it exists on the left side, even number on the right side. Okay, similarly, this is third on the left side, even number on the right side. That's why you know that it is the locus on the real axis exists in between, yeah, those poles and zeros. Yeah. Okay, direction, that is number 4, isn't it? Okay, from the pole towards the 0, you have finite 0. Okay, so you know that it need to be symmetrical about the real axis. That is rule number 2. And how many branches? It depends on the number of the output poles. There are 2 branches for this system root locus. Okay, so this is how it looks like. Alright, so obviously for this kind of sketch based on the 5 basic rules just now, okay, the 5th one you don't use it, right? Because no locus that goes towards infinity. Okay, so from the 5 basic rules, you can already sketch your root locus. And clearly you can see that there is a need to calculate the break-in and breakout points. Do you understand what I mean? Okay, that is 5. Yeah, 3, 5. And then this is minus 1. This is minus 2. Okay, so once you finish with that solution, you get S equals to minus 1.45. Another is 3.82. Now, which one is break-in, which one is breakout, you know already. Okay, because you know the points of the poles and the zeros. Okay, it's clear that minus 1.45 is for this one, isn't it? Can you see my cursor? Yeah, it is for the breakaway point because it is between the minus 1 and minus 2. Do you get what I mean? Okay, make it bigger.
Plus.
Oh, tak nampak sebab dia. Alright. Okay, I hope that you can view this. Yeah, this one. Guys, any questions so far about the break-in, breakout using transition method?
No.
Is it good? Yeah? Okay. All right, so 3.82 should be the break-in, right? Yeah, the break-in. So you can see that both points need to be used. Sometimes, even though you have two answers, okay, well, it depends on the five basic rules rockers that you have drawn. Yeah. Um, in a case where you just need the break in or break out, okay, you have to pick one of the point. You have to pick one of the point. Yeah, one of the points. Okay, so in this case, you need both points. Okay, that is why one to this point, another is to this point. Okay, now next, okay, is on how to use the differentiation method. Okay, so you can see from here, yeah, from this answer, yeah, you take the equation itself, kgh, the open loop transfer function, k s minus 3 minus 5 s plus 2 s plus 1, right? Equate it to this equate, I'm sorry, equals to this one. What is this? This is yeah, you solve it, right? You apa ni, expand it. Yeah, expand it. Okay, next. Okay, once you have got that, okay, right, remember that what's the formula. Okay, now carefully please look at this. Yeah, one, okay, okay, can I write it up here? Yeah, can I write it up here? Boleh ya? Okay, so I want to solve using the second method. 1 plus kgh. That is the formula, remember? Yeah, this one. Okay, all right. So you know the kgh already, and it's already expanded this way. Yeah. Okay. So next is to rearrange it. K equals to negative 1 over gh. Okay, all right, and that gives you, yeah, okay, that one, that is kgh, right? Okay, kgh 1 plus, oh, wait, I think it's better use this way. It's better for you to solve it this way. 1 plus, okay, put it there. Yeah, ks minus 5s minus 3 s plus 1 s plus 2 equal to 0. Okay, okay, next, yeah, what you need to do is just you arrange it. Okay, equals to, yeah, negative 1 okay, times the poles and the zeros. Okay, all right. So why I want you to start from here, because yeah, I want you to understand how to get the k equals to, yeah, that. Okay, all right, because I want you to avoid mistake of not doing the inverse. Yeah, the inverse of this goes up, this goes down. Yeah. Okay, all right, once you get that, next, dk over ds. All right, mathematics. Yeah, now you know that here, what do you get? S plus 1, s plus 2, divide by s minus 3, s minus 5, right? Okay, so here when you want to differentiate on s, it means that you have to use the um, remember your mathematics, v du minus u dv divide by v squared. Okay, so you have to do that. Okay, all right, so this is what you will get. All right, this is what you will get. Okay, please try, yeah, and see whether you get this, and then equate it to 0. Once you get your dk over ds done, then you have to equate it to 0. All right, when you equate something to 0, yeah, you can solve for the solution. Okay, and you will get these two answers, same, yeah, like what, yeah, you have used before, yeah, the transition method. Okay, try this out, yeah, using your mathematics. Okay, see whether you can get the same answer. All right, now remember the answer is given already. Can you see that? That is the result of differentiation on S for this equation. Yeah, for this equation, the result of differentiation on S is this, given to you already. Yeah, on this slide. Okay, you just have to go back to the fundamental mathematics, how to differentiate on a function that have the upper and the bottom part. Okay, the u and v. Okay, all right. So that one I don't want to go further because this is mathematics. The answers given to you, you just have to do it. Okay, all right. So please, the first one and the second one, do it. Yeah, make sure you get two answers there. Okay, if you have problem, please let me know. Yeah, so that I can get your friends who can get it. Yeah, to to explain to you. Yeah, where you might get wrong. Okay, all right. I think that we don't have enough time to go to J omega axis crossing, but I need you to cover for me this table. Yeah, please learn about this table. Probably you have to find it. Yeah, you can Google it. Yeah, you can also open up, yeah, your Ruth with topic that you have learned before. Okay, in your notes, in your previous notes. Yeah, so it's just about how to use this table. Yeah, all right. So for J omega axis crossing, yeah, this also you have two, yeah, you have two methods to cover. Okay, you have to choose any of these that you are comfortable with, yeah, to solve for the J omega crossing. Okay, right, what is this J omega crossing all about? Okay, I will explain to you a bit. Yeah, okay, let's say that you have root lockers, yeah, with for a system that you get that has let's see how many, 1 2 3, okay, 3, 1 2 3, okay, 3 open loopholes. All right, now I will show you how I draw this, yeah, using the 5 basic rules. Okay, this is a bit of revision, yeah. Okay, 5 basic rules says that 3 poles, 3 branches. Second rule says that symmetrical, yeah, any locus that breaks into the complex space needs to be mirrored or symmetrical, yeah, about the real axis. Okay, third is you have to count, right? Here you have to count the poles or zeros on the real axis. Okay, you have to count, yeah, or the odd number would have the locus exist on its left. Okay, so 1 2 3, okay, 1 and 3, so you know that it exists on the left. Is it? This is how you use it, yeah. Okay, you exercise, you practice 4 or 5 times, you will be good. Yeah, don't worry. Okay, so this is even, so you know that the locus would exist on the other side, yeah, on the right side of it. Okay, now until then, this is how, yeah. The fourth rule says that it goes from the pole to the zeros. You don't have any finite zero there. You know that all three branches would go towards the infinity. Okay, now you use the fifth rule to calculate your asymptotes. You'll get the asymptote point. Okay, and also you can calculate the angle of the asymptote. Once you get the point, once you get the angle, you can draw the lines. There would be three asymptote lines because you have three branches that goes towards infinity. Okay, now all right, the branch would bend. Yeah, the asymptote would bend. Okay, because this is a 3 poles, 2k plus 1 pi over 3 would have pi over 3 is 60 degree. Okay, so I don't calculate it now, yeah, because I want to finish, yeah, very soon. Yeah, now it's almost 9:50. Okay, so I will just let you know how this might look like. Yeah, the locus would be somehow look like this because it need to bend. Yeah, pi over 3 is the reason. Okay, the asymptote would, yeah, be bending this way. Okay, so meaning that locus need to bend. All right. Okay, this one would go towards this. Why? Okay, you have to calculate the asymptote line, the third asymptote line. Yeah. Okay. For instance, okay, if you want to try, okay, let's say that this is -2, this is -1, -2, this is -3. Yeah. So it bent. Okay. Now, can you see what happened here? Can you see what happened there? You have crossing, yeah, crossing at the j omega axis, crossing of the locus at the j omega crossing at j omega axis. Okay, here and here, because this needs to be symmetrical. Remember, rule number 2. Okay, rule number 2, you have to make sure that your locus that breaks out or break in need to be symmetrical about real axis. Okay, so here crossing happened there. That is why you have to use these two rules to calculate it. Yeah, to calculate the point. Okay, and that would be in the next class. All right, so I want you to do this for me. Okay, you can try this out. This is another example. Okay, get this one calculated. Yeah, the asymptote points and angles. You need to calculate them. Yeah, using the 5 basic rules, sketch the locus and get ready for this j omega axis crossing in the next class. Okay, all right, I think that's all for today. Yeah, we covered quite a lot. Yeah, okay, let me share with you the attendance code for today. You are group